Hi there guys, and welcome to our final video on chapter 6, sequences and series. So now we need to introduce this sigma notation. So your teachers might have used this quite a lot, especially with averages. Rather than writing like the sum of or the total, we used to say like sum of fx or something like that. Okay, so it just means the sum of the 3n. So the sequence 3n is 3, 6, 9, 12, 15, 18, blah 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 blah. It goes on forever. But when we use this notation, we can limit it rather than writing a sentence basically. So what we're saying, we want you to start from n is equal to 1 and then stop when n is equal to 10, which is the number at the top, which is just what I've said. So let me just pop the pen on here, change colour. So this tells us our starting value, and this kind of tells us our end value. Look at the next one. But like I just said, the nth term, so we're going to stop when n is 10, so it would be 3 lots of 10, which is 30, and that's where it comes from. So we have to find the sum of those numbers. So this one, un, basically means whatever u1 is, plus u2 is, plus u3 is, and we're going to stop to where we get the 10th term. That's exactly the same as what we've just put there, really. Now you can see here r, we haven't used r before, but again, when it changes to this new notation, it's quite nice to change the letter, and you'll see they like to use r, especially in the textbooks anyway. So r is going to be 0 to start off with, and we're going to stop when r is 10. So the first number when r is 0 is going to be 2, because 3 zeros are 0, and we're going to stop when r is 10, so 2 plus 32. Sorry, 2 plus 30 is 32. That's basically it. And then obviously you can see that we need to combine the knowledge of like the Karl-Gauss method of adding up arithmetic series. So let's do that. So here's a question. So we've got 5r minus 2. We're going to start when r is 1, and we're going to stop when r is 20. So if you put those numbers in, 5 1s, 5, take away 2, that's where we get the 3. 5 2s, 10, take away 2 is 8. And so on. It's basically 5n, take 2. But we're going to stop when we use this. So it's going to be 5 lots of 20, which is 100. Take away the 2 is 98. Write my formula down. Now you'll notice that I do have the first and the last, so I could have done the other formula. I just tend to use this one. Okay, n, don't know. So, oh no, we do know. It's 20. It's 20 terms, so it's going to be 10 there. So 20 divided by 2, which is 10. 2a's, the first number is 6. 20 take away 1 is 19. Times the difference, which we can see is 5. Tidy it all up, and you'll realise it's 10 lots of 101, which is just adding a 0 onto 101, and there you have it. Oh, so I only gave you the one example. So basically they're very, very similar. How they might catch you out is, let's see, where's the pen here? So if they have something like this, I have seen this before. So let's say it said that, and when you expand that, that's r squared plus 2r, and what you'll see is this is no longer arithmetic, and you'll see if we can. Let's see if we can do one quick. So let's say if we said r is 1, and we're going to stop at 5. So when r is 1, that's going to be 1 plus 2 lots of... So I shouldn't be writing that there. Let's put this in there. So when r is 1, that's going to be r squared is 1 plus 2 lots of 1 is 2. 1 plus 2, you're going to have 3. When r is 2, that's going to be 4 plus 4, which is 8. So you can see here, this is going up in 5. So if it is an arithmetic series, this next one should be 13, but watch what happens. So when r is 3, r squared is 9, 2r's would be 6, 9 plus 6 is actually 15. And when r is 4, well, actually let's skip that. So we're going to put ... plus r is 5. It's 25 plus 10 is 35. You cannot use this formula. You cannot use the a plus l variety of it because it's not arithmetic. Arithmetic means it has the same constant difference. You can see here it's going up in 5, then it's going up in 7. We skipped one, but you should be able to realize it's going up in 9, so that bit there is going to go up in 9, which would in fact be 24, and then the next one is going up in 11. You cannot use these formulas. The way to spot it is if you have a quadratic. If it's quadratic, it's not linear. It's not going to go up by the same amount, and therefore the only thing you have to do for these, they're not going to have this number very high. You just physically add the numbers up like I did right at the start of this video. So 3 add 8 add 15 add 24 add 35, that's how you get your answer. Okay, best of luck with those.